In this video, I want to show you how to take the square root of a negative number. Now, when we take the square root of something, we're trying to find the integer that when you multiply it by itself, gives you the number that's underneath the root. However, we can see here that we're never going to find a number on the real number line, such that when you multiply it by itself, it's going to give you a -4. To make this work, we're going to have to extend our domain. We're going to have to extend the real numbers onto the complex numbers. So let me introduce the imaginary unit. From now on, we'll say that the square root of -1 is going to equal I. If you square both sides, you can see that on the left hand side, the square and the square root are going to cancel out. So we also get that -1 is equal to I squared. So these are going to be our two new exchange rates. Whenever we see the square root of -1, we can exchange it for an I. And whenever we see an I squared, we can exchange it for a -1. And to get the square root of negative numbers, we're going to use this part. The square root of -1 is equal to I. So let me show you how to do this. The square root of -4, we can rewrite that as the square root of -1 multiplied by 4. Now, because we have a monomial here, we can distribute the radical to each individual term. So we can rewrite this as the square root of -1 multiplied by the square root of 4. The square root of -1, we will use our new exchange rate. We're going to get I. And the square root of 4 is going to be 2. It's a custom to always put the real number in front of the imaginary unit. So here, I'm going to write it as 2i. So the square root of -4 will be 2i. Let's try another example. So here I have the square root of -180. So here 180 doesn't have a perfect square. However, I can still simplify it. I'll get the prime factorization. So the 180, I can break that down into a 60 multiplied by 3. And the 3 is prime. Now I can break down the 60 as a 6 times 10. The 6, I can get it as 2 times 3, and the 10, I can simplify it into 2 times 5. So now I have all of the primes. Because I'm taking the square root, I want to get the pairs. So I'll rewrite the square root of -180 as the square root of -1 multiplied by 2 squared multiplied by 3 squared and then multiplied by 5. I have a monomial, so I can distribute the radical to each number here, each value. So I get the square root of -1 multiplied by the square root of 2 squared times the square root of 3 squared times the square root of 5. I can exchange the square root of -1 for I. Here, the square and the square root are going to cancel out, so I get 2. The same thing happens with the 3. And I'm left with the square root of 5. Simplifying, I'm going to get 2 times 3, which is 6. So I get 6 root 5, or 6i root 5 is equal to the square root of -180.